Alright, what's up guys? In this video we're going to pick up with some calculus here. We're going to do another integration practice video. So I'm going to evaluate the integral 1 minus x squared raised to 3 over 2 all over x to the 6th power dx. Alright, so believe it or not, we can actually do a trig substitution for this. Remember, we don't need a square root to do a trig substitution. We just need to have either the sum or difference of squares. So in this case what we have is a squared minus x squared. So we can use a trig substitution. So for 1 minus x squared, that's just going to be x is equal to sine theta. We need dx, which is the derivative of it, so it's just going to be cosine theta d theta. Alright, so we'll go to the integral now. So this would be 1 minus sine squared theta raised to the 3 over 2, all divided by sine to the 6th theta multiplied by cosine theta and then d theta. Now this just becomes cosine squared theta raised to the 3 over 2 all divided by sine to the 6th theta multiplied by cosine theta and then d theta. Okay, and this just becomes cosine to the 3rd theta because these 2's cancel out, but I do have an extra cosine theta over here, so if I multiply cosine to the 3rd theta times cosine theta, that's cosine to the 4th theta. So this becomes cosine to the 4th theta all over sine to the 6th theta d theta. Now we need to solve this or evaluate this trig integral. Okay, well, remember that cosine theta over sine theta, that's cotangent theta. So what I'm going to do is I'm going to rewrite the integral as cotangent to the 4th theta all over sine squared theta d theta, if I use that identity. And I can rewrite this integral even better as cotangent to the 4th theta times 1 over sine squared theta d theta. Now remember, this is the same thing as that because cotangent to the 4th theta over sine squared theta, if I multiply cotangent to the 4th theta times 1 over sine squared theta, I get the same thing as that, so I can separate it. Now why did I separate it in the first place? Well, remember that 1 over sine squared theta, if I use a reciprocal identity, that's going to be cosecant squared theta because 1 over sine is cosecant theta, or 1 over sine theta is cosecant theta. And so then we got cotangent to the 4th theta times cosecant squared theta d theta. And this is a great integral to have because if I let u equal cotangent theta, its derivative is in the integral. It's in the integrand, although it's not the exact derivative because the derivative of cotangent theta is negative cosecant squared theta, but it doesn't have to be exactly the same. We just need to be able to get rid of something. So the cosecant squared theta will cancel out. We'll still have a negative hanging around, but the cosecant squared theta will go away. And so what we'll end up with is negative u to the 4th du. And then this just becomes negative u to the 5th over 5 plus c. Now remember that u was cotangent theta, so if we put that back in there, we end up with negative cotangent to the 5th theta all over 5 plus c. Okay. So as you can see, even though we're doing a trig substitution here, you can see how having your other trig identities memorized is very important. The Pythagorean ones are definitely the ones that you need to know for trig substitutions, but you need to know the other ones too, because as you can see, we're using the other ones. So it's not just the Pythagorean ones that you need to know for trig substitution, you need to know the other ones. Now you don't learn trig substitutions until after you've done basic trig integration, so you'll be familiar with using trig identities, but just pointing that out, very important to remember. Now we go back to the substitution that we did at the beginning. Remember, x was equal to sine theta. So let's solve that for sine theta. So that means that sine theta here is going to be equal to basically x over 1. And if we solve for theta, then that's going to be theta is equal to arc sine or sine to the negative first of x over 1, which is the same thing as theta is equal to arc sine of x because x divided by 1 is it's going to be x. Now, if we go back to some right triangle trigonometry, remember that SOHCAHTOA Remember sine theta, that's opposite over hypotenuse. Now, since we saw for sine theta already, that means that the opposite side is x and the hypotenuse is 1. Now, since we have cotangent, we need cotangent. So remember, cotangent would be the reciprocal of the trigonometric ratio for the tangent. So since tangent is opposite over adjacent, that means that cotangent, or in this case theta, let me be more specific, would just end up being adjacent over opposite. Now, we have the opposite side already, but we don't have the adjacent side. The opposite side is x. So we're going to have to find the adjacent side. And that's easy enough to do. We just use Pythagorean theorem. So a squared plus b squared is equal to c squared. Since we have the opposite side already, we plug that in, have the hypotenuse already, plug that in. So if I square x, I get x squared. We're looking for the adjacent side, so we need to solve this equation for b. And if I square 1, I get 1. So this would be x squared plus b squared is equal to 1. If I want to solve this equation for b, I'll get b is equal to the square root of 1 minus x squared. So that's actually going to be the adjacent side that we need. So you don't have to draw the triangle, but it does help sometimes. And so the hypotenuse is 1. Remember, the opposite side is x, and the adjacent side, which we now have found, is the square root of 1 minus x squared. So now we have the ratio that we need, trigonometric ratio we need for cotangent theta, which would be the square root of 1 minus x squared all over x. Okay, so now we continue with the integral, and we're almost done, believe it or not. Okay, so let's quickly go back. So remember that we had negative u to the 4th du. Remember we had that, and that gave us negative u to the 5th over 5 plus c. Remember, and remember we put the u back in, so that was negative cotangent to the 5th theta all over 5 plus c. But now we have the trigonometric ratio for cotangent, so we can put that in now. So now what we have is, it's a negative, by the way. Now what we have is the square root of 1 minus x squared all over x. That's being raised to the 5th power, all divided by 5, and then plus c. But we need to simplify that a little bit. Okay, so I can simplify that and write that as negative 1 minus x squared raised to the 5 over 2, because remember that the square root of 1 minus x squared, I can write that as 1 minus x squared raised to the 1/2, and if I imagine raising that to the 5th power, then that just gives me 1 minus x squared raised to the 5 over 2. Okay, and then we'll have to apply the fraction rule. And don't forget that we're raising that x to the 5th power as well. So by raising that x to the 5th power and applying the fraction rule, we end up with negative 1 minus x squared raised to the 5 over 2 all over 5x to the 5th power, and then plus c, which will actually be your answer. So your final answer for this integral here we're asked to integrate 1 minus x squared raised to the 3 over 2 all divided by x to the 6th power dx. And our final answer for this is just going to be negative 1 minus x squared raised to the 5 over 2 all over 5x to the 5th power plus c. And that's your answer. All right, so let me circle that for you. And that's your answer. All right, so hopefully these videos are helpful, and just me sharing with you some of my strategies on how I deal with some of these integrals. Again, I have a degree in physics. I took 6 semesters of calculus when I was an undergrad in physics, so I have so much calculus practice, and I've been tutoring net calculus for years. So that's really where all of the me being good at calculus, that's really where it's come from, just doing a bunch of practice and a bunch of tutoring and taking a bunch of calc classes. So reach out to me if you have any questions. I'll be more than happy to help you. I'll see y'all next time. Y'all take care.